Hello. In this video, we're going to look at a few remaining topics from our trig unit so far. The first one is we need to sketch the graph of tan x. Now we sketched sine and cos, but we've never actually taken a look at tan. So let's go ahead and make a quick table of values here. So we know at 0 degrees, tan of 0 is going to be, remember, tan is sine over cos. So sine of 0 is 0 and cos of 0 is 1, so 0 over 1, which is 0. Now 45 is a nice point because at 45 sine and cos are the same. They're both root 2 over 2, root 2 over 2, so that's going to give you 1. And at 90 degrees, sine is 1 and cos is 0, which means it's going to be undefined. Similarly, at negative 45 degrees, we're going to have the same value, but one of them will be negative. So this will be negative 1. And at negative 90, we're going to have the same undefined problem. This time, sine will be negative 1. But negative 1 over 0, you still can't divide by 0. So we get 3 points here. 0, 0, 45, and 1. Negative 45 and negative 1. And then we have these undefined points at 90. Now these are going to generate vertical asymptotes. So we can go ahead and throw those on the graph. And then we basically just connect the dots. So you kind of have something like this. And there you go. That's our graph of tan. Maybe it's a little bit extreme there. Maybe try to level that out. But yeah, we have this sort of S-curve in between the two asymptotes. And then, of course, we would just repeat because this here is one period. One period of the tan graph is actually just going to be from negative 90 to 90. So it's just 180 degrees. It's half the period of sine and cos. And then we would just take that graph and we would repeat it. So we'd have another graph over here, and then another one, and then another one. And you just keep repeating this tan graph. Let me show you on Desmos what it looks like. All right, so here we have our tan graph. And so we can see that nice, beautiful shape here. We can see there's some asymptotes. This one is actually sketched in radians. So the asymptote will be at x equals pi over 2, which is 90 degrees, but in radians. And then the other asymptote will be at x equals minus pi over 2. Minus pi over 2, which again is minus 90 in radians. So there we go. We've got our basic version of tan, which is just this section in between the asymptotes. And then we just copy paste to make more copies either direction. Now, we're not going to do a lot of transformations with tan. I don't want to do stretches and translations and reflections and all that stuff. It's mostly just looking at the basic version of tan. You might be asked to do maybe a simple transformation, but really the main transformations happen with sine and cos. For tan, it's just more important to know kind of this basic graph. You know, have a couple points on the graph, right? Here, you know, maybe over here, here. Grab those couple points, something like that. Maybe that second point here will be at the 1, right? Grab a couple points, grab the asymptotes, and then sketch the graph. That's all we're really looking for the tan graph. All right, now moving on to something totally different. Let's look at the following question. This is going to be a calculator question. If theta terminates at the point root 13 and 6, determine theta. Okay, well, this is kind of a weird question. But at the end here, we're just trying to clear up any final little topics. So the first one we had there was the graph of tan. Now we have something with a point. Let's see, how would we do this? Well, we could put the point on a graph. So we'd have root 13, which is approximately, remember we want to think of numbers, so it'll be between 9 and 16. Square root of 9 is 3, square root of 16 is 4. So it's approximately maybe 3.5, somewhere around there. So we got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So I don't know, somewhere like there. Okay, that's and this is sort of like a terminal arm like that. And we're looking here for theta. How do we determine theta if this point is root 13 and 6? Well, we have a calculator, and so what we can do is we can actually draw ourselves a little triangle here. So there's a little right angle. Because it goes up 6, we know the height of this triangle is 6. Because it goes to the right, root 13, we know this is root 13. And we're looking for, maybe let me put that theta down in the corner. We're looking for this angle right there in the triangle. And that means that based on that angle, this side is the opposite side. This side is the adjacent side. And so that means we're going to use TOA, or tan. Tan of theta equals opposite over adjacent. This is some basic SOHCAHTOA work. 6 over root 13 equals tan of theta. And then we do tan inverse of both sides, so theta equals tan inverse of 6 over root 13. Now make sure your calculator is set to degrees if you want to get your answer in degrees, or radians if you want it in radians. They didn't say here, so we can do either or. Let's do degrees, 58.997 degrees. Make sure you go to 3 decimal places. And okay, sweet, we got our answer. Let's continue studying this though. If theta terminates at the point root 13 and 6, could you determine tan of theta? Well, you might say, oh, okay, well, this is like step 2, right? Step 1 was theta equals to 58.997 degrees. Step 2 is just do tan of 58.997. Okay, so we have that number. We can do tan of 58.997. Hit equals. Again, make sure you're in degree mode. Degree mode. Right, we're working with degrees. Okay, so tan of that gives you 1.664. Okay, sweet, we got our answer. But what if we were to do this without a calculator? I mean, that seems kind of impossible because step 1 needed a calculator for that tan inverse step. But then step 2, we kind of like redo the tan. Is there a way to get this number over here without a calculator? So let's try now without a calculator. Without a calculator. Well, we can draw our little diagram again. Here's our point at root 13 and 6. And so that means this side is 6 and this side is root 13. Here's our theta. Well, again, based on our little triangle here, this is opposite. This is adjacent. So tan of theta equals 6 over root 13. And, well, we were asked to find tan of theta, so I think that's our answer. Let's try it on our calculator. Let's get an approximate answer for this. If we approximate 6 over root 13, my calculator says 1.664100 and so on. So it's approximately 1.664. This is the exact value of this thing. Oh, okay, so that's kind of cool. And if you notice, we can do the math to get 6 over root 13. We don't actually have to use a calculator. If we want to find the exact theta value, you definitely need to have a calculator for that. But if you want to find the ratio, tan theta, which is a ratio, well, a ratio means you haven't actually done any tan inversing yet. You're just looking for the opposite side, the adjacent side, and we can totally do that without a calculator. Okay, let's take it one step further. Can we find all of the ratios? Can we find the exact value for each one of those trig ratios? Well, let's draw the diagram again. Right, here's our point. Root 13 and 6. We got our triangle here. This is going to be 6. This is root 13. Now we're missing one of our sides, which we're totally going to need, right? This is going to be the hypotenuse. And if we want to find all of the ratios, a few of them are going to need hypotenuse. So how do we find that missing side, the hypotenuse? Again, we have no calculator here, okay? This is without a calculator. So pause the video and give it a try. All right, so assuming you figured out the Pythagoras here, right? Root 13 squared plus 6 squared equals c squared. 13 plus 36 equals c squared. 49 equals c squared. And this just so happens to be a perfect square, which is nice. So C equals 7. All right, well, with that in place, I think we can do them all. So let's start with sine. Based on SOHCAHTOA, sine theta is opposite over hypotenuse, so 6 over 7. Cos is adjacent over hypotenuse, which is root 13 over 7. Tan theta is opposite over adjacent, so that's going to be 6 over root 13. Now, cosecant is just the flip of sine, the reciprocal of sine, so 7 over 6. I don't remember cosecant as like hypotenuse over opposite. I just remember it as the reciprocal of sine. That's how I think of cosecant. And then for secant, well, that's just going to be the reciprocal of cos. So we just flip this one, 7 over root 13. Cotan, one more flip, root 13 over 6. And boom, we've got all 6. All 6. We're done. It's awesome. Now, what if theta terminated in quadrant 3 and we weren't given the point? We were only told cos of theta was negative 7 over 8. Could we find the exact value of tan? Ooh, this is a little tricky. So I'd encourage you to pause the video and give this one a try. Again, draw a diagram and see what you come up with. All right, so assuming you gave it a try, let's go ahead and start off with a diagram here. So we've got the point, or the trig ratio, I'd say, negative 7 over 8. And we know we're in quadrant 3. So the first thing we can do is we can draw a little triangle in quadrant 3. And the important thing here is that we always draw it along the x-axis. So this is important. When you draw the triangle, you want to draw the triangle along the x-axis. So this would not be good if instead somebody drew a triangle like this along the y-axis. That would not work out. So just always draw your triangle along the x-axis. Now once you've got that, you can start to think, oh, you've got cos of theta, which is supposed to be, well, cos is adjacent over hypotenuse, right? SOHCAHTOA. And so based on a little angle down here, theta, adjacent would be here. This would be my adjacent side. And my hypotenuse would be over here. Now cos is negative 7 over 8. And the rule here is that, well, I mean, just look at it. The x is going left. The x is negative. So you put the negative sign, even though it's just in front, put the negative sign with the 7. So this length is negative 7 because it's going left on the x-axis. But then the hypotenuse here will be 8. Hypotenuse will be 8. Again, another little rule for drawing these is the hypotenuse is always positive. All right, so we're almost kind of like working backwards. We know that cos theta is negative 7 over 8. That allows us to draw a little triangle. The triangle has sides of negative 7 on the x side and 8 on the hypotenuse side. Now, can we do that to find tan? Well, tan is TOA. So tan is opposite over adjacent. But opposite's over here, and we don't have the opposite side. Oh, man. But that's okay. A squared plus b squared equals c squared. We can still do that. So we got negative 7 squared plus b squared equals 8 squared. So 49 plus b squared equals 64. B squared is 64 minus 49. That's going to be 15. And so b is equal to root 15. Now, technically, when we square root, we get a plus or minus, and we do have to be careful here because the b is going down. If you notice, this is going down the y-axis. This is a negative direction. So this is going to be negative root 15 for my opposite side. All right, putting that all together, tan of theta is equal to negative root 15 over negative 7, which we can simplify to root 15 over 7. Boom, there's my answer. Now, one last thing we can do to check, if you remember the cast rule, C-A-S-T, in quadrant 3, tan is supposed to be positive, which it is. We have a positive root 15 over 7, so that's definitely the correct answer. Okay, so let's do another one of these. We're going to be told that theta is in quadrant 2, tan is negative 1 over 4. Determine the exact value of sine and cos. So sine of theta and cos of theta. Pause the video and give it a try. All right, it's the same idea. We draw a little triangle in quadrant 2. Remember to draw it along the x-axis. Tan is opposite over adjacent. So opposite will be 1. Adjacent is 4. Now, if you think about it, one of these has to be negative, right? The negative sign has to go either as a negative 1 over 4, or you could write it as 1 over negative 4. And again, based on the diagram, the 1's going up, but the 4 is going left, so the 4 is going to be negative. Now, I maybe didn't draw this triangle all the way to scale, but that's not really a big deal. We're just using the diagram to figure out which side's opposite, which side's adjacent, right? This is our theta in here. So here's our adjacent, here's our opposite, and here's our hypotenuse. All right, well, if we're going to find sine and cos, we're going to need the hypotenuse, so let's go ahead and rock and roll. A squared plus b squared equals c squared. Negative 4 squared plus 1 squared equals c squared. 16 plus 1 is c squared. 17 is c squared. And c is root 17. Now again, because the hypotenuse is always positive, we can put this just as a positive root 17. Ignore the negative root. Now it's time again for SOHCAHTOA. So SO and CA. Sine theta is opposite over hypotenuse, which is 1 over root 17. Cos of theta is adjacent over hypotenuse, which is negative 4 over root 17. Now, you don't have to rationalize these on the final exam. You can just leave them like this. I like to rationalize stuff, but I guess if you want to leave it, that's okay. And then if we, again, check with our cast rule, C-A-S-T, in quadrant 2, sine should be positive, which it is, and cos should be negative, which it is. All right, let's go ahead and take some notes on this. We did 2 quick concepts today. We did the sketch of tan theta, and we did trig ratio diagrams. And the important thing is these are without calculator. Without calculator. Oh, that's a bit of a mouthful for a title. So tan theta, if this is our y equals tan theta, basically just looks like this. We grab a couple points here. Boom, boom, boom. Couple asymptotes. And there's our graph of tan theta. Remember, the period is 180, or simply pi if it's in radians. The asymptotes are at 90 degrees, or pi over 2, and minus 90 degrees, or minus pi by 2. Now, for the trig ratio diagram, probably just best to give this one a try. So as an example, we'll say theta in quadrant 4, and I'll tell you cosecant theta equals negative 5 over 4, and your question is to determine cos of theta. So go ahead and pause the video and give that a try. All right, assuming you gave that a try, let's go ahead and draw our diagram here. In quadrant 4, we're going to draw a little triangle. Cosecant means that we're looking for, well, we're given, I guess, sine of theta as negative 4 over 5, right? Cosecant's kind of weird, so let's turn it into sine. And we know that sine is SO from SOHCAHTOA. So that means we know that the opposite is going to be negative 4, and the hypotenuse is 5. Again, we know it's negative 4 because we're going down. This is going to be adjacent side here. Here's our theta. To find adjacent, we use Pythagoras. So a squared plus negative 4 squared equals 5 squared. A squared plus 16 equals 25. a squared equals 9, a equals 3. It's going to be a positive 3 because we're going to the right. So cos of theta, which is equal to adjacent over hypotenuse, is going to be 3 over 5. And we can check it with the cast rule. C-A-S-T. All of them should be positive in quadrant 1. And cos should be positive in quadrant 4. Sine should be positive in quadrant 2. Tan should be positive in quadrant 3. We're in quadrant 4, so cos should be positive, and indeed it is. Okay, so for some extra practice, you can look at worksheet 11 and 11.5. And some things to remember. Definitely when you're drawing that diagram, there's a few things to remember. You always want to draw the triangle on the x-axis. So if you were looking at the 4 different options, right? Triangle here, triangle here, triangle here, triangle here. Always draw it along that x-axis. Sorry, the last triangle looked a little bit bad. There we go. So that's one thing to remember. You also want to remember that if the side is left or down, then it's negative. And maybe even one more thing to remember is that the hypotenuse is always positive. I mean, there's so much we could write down to remember here, right? We could remember the cast rule, we could remember SOHCAHTOA, but these are things you probably already know, so don't overload your things to remember section. All right, hopefully you enjoyed this video, and as always, thanks for watching.